Hey guys, Chemistry Faster with another chemistry video. Today we will be doing Gases Galore 1, part 1 of 3 videos I'm gonna make for gases. Let's get started. First thing you need to know is the properties of gases. Here's the atoms of a solid substance. Here are the atoms of a liquid substance, and here are all the atoms of a gas substance. As you can see, the gas molecules are far more spread out from each other than liquid or solid, and because of this they fill their container's shape, they expand indefinitely, they never stop expanding, and they are easy to compress, and well, obviously they occupy far more space than solids or liquids. That's pretty much all I need to know about that. Oh, and one little side note here. All colored gases are poisonous. If you're just chilling in lab and this brown gas starts coming out of your beaker, run. Red? Even worse, just get out of there. Don't breathe it in. You'll die. Or, get ill. Okay, so that's all about the properties of gases. Now let's get on to some of the principles of gases. First one, Avogadro's hypothesis and principle. Avogadro, remember this guy? He's the guy who said, Avogadro's number that there are 6.02 times 10 to the 23rd molecules of any element or compound in 1 mole of said element or compound. Well, he pretty much said the same thing about gases. The exact wording is, the principle that equal volumes of all gases given the same temperature and pressure contain equal number of molecules. Which pretty much means, say you had a 3-liter container at 1 atm pressure and 298 degrees Kelvin. If you fill that container tip to the top all the way full of oxygen gas, you're going to have blank number of molecules. Now if you empty it out completely and fill it again with, let's say, nitrogen gas, all the way to the top, same volume, you're going to have the same number of molecules. Then that's what Avogadro said about gases. Now let's get into the conversions of gas laws and such. So you're going to need to be able to convert some temperatures and some pressures. Let's start with the temperatures. The main temperature you need to know how to change to is Kelvin, which is represented by capital K, or kelvins. And kelvins is 1 degree Celsius plus 273. That's it. You take degrees of Celsius and add 273, you got degrees Kelvin. So for example, say you had 25 degrees Celsius, convert that to Kelvin. Well, K equals C plus 273. K equals 25 plus 273. K equals 298. 25 degrees Celsius is 298 degrees Kelvin. It's really that simple. Straight just adding on. Nothing special. So you're going to need to know how to get to kelvins from Celsius. The other type of conversions are pressure conversions. And there's mainly 3 units of pressure you're going to be using. There's atmospheres, ATM, kilopascals, kPa, and millimeters mercury, mmHg, which are the same things as torr, represented by TORR. Torr equals millimeters mercury. They're the same measurement. Different names because if you only got one name, it wouldn't be confusing enough to be called chemistry. But yeah, so torrs are millimeters mercury. First conversion, you're going to need to know how to get from millimeters mercury, kilopascals, torrs, to ATM. You're probably not going to have to go the other way, but you're definitely going to have to go to ATM. So 1 ATM equals 1 ATM equals 760 millimeters mercury, which is the same thing as saying 1 ATM equals 760 torr. So let's just practice conversions. Say you had 75.0 millimeters mercury, convert to ATM. I recommend using factor label, also known as dimensional analysis, to solve these problems. If you don't know how that works, I don't think I have a video for that, but I will soon, so, check it. Anyway, that made no sense. Pretty much what you want to do is you start in the given box with the gas. So you have 745 millimeters mercury. Sorry, let me rephrase this. Let's go back for a second. If you don't know how to factor label, check out the website. It tells you there before trying to understand this, because this is factor labeling. So you start in the first box, plug in the given of the problem, 745, 745. Then you fill it out like a normal factor label. In 760, there's 1 ATM, which means you do that division, 74.5 divided by 760, 0.98 ATM. So 745 millimeters mercury or 745 torr is equal to 0.98 atm. If you don't believe me, let me just do a little calculator right here. Standard. See, right there, 0.98. Cool. Okay, next one. You're going to have to get to atm from kilopascals, and for 1 atm, there's 101.325 kilopascals. So, example, convert 98.35 kilopascals to atm. Just set up a simple factor label, and in case you just want to see it done, because you don't believe me, because I'm not trustworthy to you. There you go, 0.97. Wow, what are the odds that they're like right next to each other? There's really no significance that this was 0.98 and this is 0.97. It just happened to turn out that way. Yeah. So anyway, 98.35 kilopascals is equal to 0.97 atm. No correlation, just happened to work that way. Cool. Okay, and that's it for part 1 of the 3 parts on gases. If you like this video, click that share button with anybody that you think needs help with this topic. Got any questions? Leave a comment down below. Check out my website, http.com, or no, those are the two. Comment or website. See ya next time.